Hello and welcome everyone to ActInf Lab. This is ActInf Livestream number 21.1, and we're here with John Boik and several other colleagues looking forward to a discussion today on this science-driven societal transformation series and project that we've been exploring and had several background sessions, 0.01 through 0.04, with John. And in the discussion today and next week, we're going to be looking to draw out some threads and include some new perspectives and hear from the questions that people may have. And for these discussions, we're going to be using the same Jamboards that we were using for the discussions with just John and I. And we're going to jump around the Jamboards. We're going to hear questions from anyone who wants to ask live or in the YouTube chat, and we'll have fun. So we'll just start with introductions and then get a quick little recap and off we go. So I'm Daniel. I'm a researcher in California, and I'll pass it first to Alex.
Thanks. Hi everyone. I'm Alex. I'm a researcher in Systems Management School in Moscow, Russia, and I pass it to Steven.
Thank you. Hi, I'm Stephen. I'm based in Toronto. I do a lot of work with participatory theatre and community development, and I'm researching how social topographies can be used across scales of community psychology and other development practices. And I'm going to pass it over to Lee.
Thanks, Stephen. I'm Lee. I'm a researcher based at the University of York. I'm studying systems transformation, and my supervisor is Johan Fazy, who I think you draw on a little bit, John, in a couple of these papers.
Yeah,
so I was really happy to find someone else looking at systems transformation and active inference at the same time. But although I think you're a lot further down the line than I am in thinking about this, so really looking forward to this session.
Cool. Well, welcome, John. Maybe you could give an introduction and start things off.
Sure. Thanks for having me, and thanks everybody for joining us. My name is John Boik. I'm a courtesy faculty at Oregon State University, and the purpose of these talks is to discuss the series of papers that I just recently published in the journal Sustainability. The title is Science-Driven Societal Transformation, Parts 1, 2, and 3. And if you would go, we're going to do a quick recap of some of the material that we've discussed before. We'll jump around a little bit just to catch some main highlights. And of course, feel free to jump in with any questions as we go. So if you could turn to Jamboard 1, slide 1.
Yep.
You got it? Okay, good. So this just is the pictures of the different papers. The links are down on the lower left, so in case anyone wants to check out the papers, please do. They're all open source, freely available. And we're going to focus today. We'll jump around a little bit and capture the main topics, but we're going to focus on part 3, design, today. All right, slide 2, please. And as we go through this, if there's more questions, if someone wants more materials, all of the links are available. All the links to all the papers and some other materials are available at my website for this project, principledsocietiesproject.org. And I might mention there's also an interactive model there that you can, the LEADA framework, which we'll talk about. So you can see how the economic simulation goes. Slide 5, or slide 4, excuse me.
Yes.
So what is the purpose of this? What is the problem that this series is trying to solve? The problem that faces society, or really human civilization, is a host of very large, so far intractable problems, including climate change, biodiversity loss, poverty, income and wealth inequality, and soil depletion, groundwater depletion, pollution. I mean, it's a long list of very serious problems that we face. So serious, in fact, that it's not clear at this point how civilization will fare in the coming decades. even in the coming years. I mean, the world is armed right now. The world is armed to its teeth with nuclear weapons. So, you know, any moment things could go awry, or things could just deteriorate rapidly as climate change and biodiversity loss gain speed. So hopefully we will solve our problems, hopefully as societies. Hopefully we will improve quality of life and quality of the environment. But that is what we're shooting for in the series, is pathways to do just that. I would like to point out that this series is focused on transformation in the sense of de novo design of fundamentally new systems, societal systems, which I talk about 6, I believe. So economic systems, legal systems, financial systems, governance systems, things like that. So the problem is the major constellation of problems that we face globally, and the proposed solution is to view society as a cognitive organism. And just like any organism, it has an intrinsic purpose of achieving and maintaining vitality. So how does it do that? How does any organism survive? It learns, it develops, it learns, it acts, it learns from its actions, and it adapts to new conditions as necessary. This series is actually an R&D proposal. It's aimed at the global scientific body, and my hope is to interest the scientific world in this problem of how do you transform? How could we build a better society? What if we were to create any conceivable way to organize society, any conceivable economic systems or governance systems or legal systems, educational systems? What would be the best in terms of quality of life and quality of the environment and long-term sustainability? I think that's a question that science is now capable of addressing. Perhaps this is the first time in history that science had the tools and the skill and the background and the computational power to address these kinds of very, very large questions. But I think that we can do it now. The whole R&D program is described as a partnership between the global scientific community and local communities. So the idea here is to test and to build, create, and test new systems at the local level in cooperation with local volunteer communities. And I talk about implementing those systems and implementing field tests via a club model, which we'll discuss a little bit more. Okay, so that's a very quick overview. Maybe on to slide 5.
First, Stephen with a question, and then anyone else who's raising their hand. So
Sure.
we'll just keep looking at the hands. Yeah, go ahead, Stephen.
Thank you. Yeah, I was just one question. I noticed you mentioned architecture. So you've got the idea of architecture, and you've got these different things that we have got in the constellation. And I wonder if you could speak a little bit more to the idea of architecture and how that relates to architectures in the brain, or maybe distributed systems of the brain.
The brain is what I'm thinking of when I use the word architecture. Well, a little bit. I mean, people talk about computing frameworks and computing architectures too, but I really had in mind the way the brain functions. And I mean, maybe I should make that even more broad, because if climate change and biodiversity loss and these other major problems that we face are symptoms of a cognitive dysfunction at the societal level, I mean, that's what I would call it, a societal dysfunction, a cognitive dysfunction, because we've known about these problems for decades. You know, with climate change, we've known about it for more than 50 years. And yet we've failed to, adequately address the issues. So I would say that all of these major problems are symptoms of a cognitive problem, or symptoms of a cognitive dysfunction. And then the question becomes, okay, well, if we're not cogniting correctly, where do we look for better models? Where do we look for ideas of how we might cognate better? And I would say that in the world of biology, including the human brain, there's just, a million or a large number of examples that we can learn from. How does nature compute? Nature's been at this for a very, very long time, and how does it work in nature? And maybe we can align ourselves with the same program, the same process that's going on all around us. And if we do, then I would say there's the chance of building systems that are much more effective at achieving the intrinsic, our goal, which is to achieve and maintain vitality far into the future.
Yeah, Stephen, and then Lee.
And I was just going to sort of building on that, because with active inference, one thing that sometimes comes up in is that rather than the brain being like a computer per se, that it's a distributed, and actually now maybe even not even functionally specialized in certain regions, but it's more of a distributed system of which we're not exactly sure exactly how all of that works, but the idea of it being a dynamical sort of prediction engine. So I'm wondering how that could how much might that inform where you go with this?
Totally. Because we're using the word brain, but even when I'm thinking brain, I'm thinking whole body and bodies connected to each other bodies in society. In part one of the series, the title is called Worldview, and I try to set up a context for all of this. And as part of that context, I point out that everything is intelligent. Like every piece of life is connected to every other piece of life, either strongly or weakly, and the whole of life is processing information. I mean, that's essentially what life is doing, is processing information, reducing the uncertainty about the past or about the future from the past. So yes, absolutely. We have the 4 E's, for example. And we have distributed, like in part 3, I use the analogy of between neurons and individuals in a society. And so how do neurons associate with other and disassociate with other? There's a kind of a complement as to how people associate and disassociate with others in the process of societal cognition. And so we have connections in the brain, we have connections to our bodies, connections to our emotions, connections to our feet and fingertips, and connections to everything that is happening around us in our immediate environments, connections to each other, and all of that plays a role in cognition. Right? So I'm talking about cognition in the large sense, not in the narrow sense. And I'm certainly not talking about a computer model that tells everybody what to do. That's not at all what this is about.
Thanks, John. Lee, and then anyone else who raises their hand.
It's more of an observation, really. It's just when you were saying that you were drawing on the natural biological systems for inspiration, it kind of occurred to me that then what you're doing is a kind of a biomimicry of cognition.
Yes.
But building on Stephen's point, it's not in the older sense of the mind is computer, but much more in the kind of the newer sense as biology at all levels being able to cognate.
Right. Right. Absolutely. I think I read by Buckminster Fuller. He said something one day. He said, "I think I'm a process, not a thing." I'm paraphrasing there, but that's right. It's like all of life is a process. An intelligent process.
Cool.
And those just I'll say it again, but those ideas really are new to science and what the mainstream science, new to mainstream science in just the last 2 decades or something like that. I mean, fairly recent concepts of complex systems, that cognitive systems. The interconnectedness of all things, the intelligence of all things, trees communicating with other trees through soil, fungus, and all of these, many of these ideas are actually quite recent in the science world.
And a funny note on that is that mainstream science is new in the social cognition world. The professionalization of science is a new topic and a new genre. And I really like some of these points about distributed systems. We can think about distributed systems within one level of analysis or one system of interest, like within the ant colony, it's a distributed system, or within the brain, it's a distributed system. But once you start thinking about brains, John, you mentioned the 4E, the extended, inactive, embedded, encultured. It could be more E adjectives, but that brings out the richness and says, yes, it's distributed system amongst the neurons in the brain. And then the brain is interfacing with the body, and the body with its niche and the tools and the social affordances. And it's starting to sound like a lot of topics that we've talked about on ActInf live streams. So it's awesome to see how we're taking some threads from the past and weaving them together. And I hope that we can draw this out, how a multi-scale distributed systems perspective on cognition, coupled with a social transformation agenda and preference vectors representing policy, can get combined through active inference into something that's applied.
Right. How to act, how to make decisions under uncertainty. That's what all of this is about. As a counterpoint to some of that, or as a different view on some of what we just talked about, imagine if we can look at how our society treats individuals. I mean, we can look at extreme inequalities of wealth and income, different levels of access to healthcare. Like there's all these issues, social issues that we face right now. Imagine if your brain acted that way somehow, with different neurons, where some neurons were just simply starved, some neurons were excluded from the computational process, some neurons were given very few resources, just barely enough to survive, and others had so many resources that they were like wasting their resources because they had so much. I mean, imagine how well the brain, or how poorly the brain might function if that's the way neurons interacted, if that was the community, if the community of neurons was anything like the community of individuals in our society, we wouldn't be able to make hardly any good decisions. We'd be a mess. And we are a mess.
It reminds me of Dennett's fame in the brain model. And the firing rates of neurons are not identical. Some are firing many times per second. Others fire not even in a day, perhaps. So there's a lot of distributions in these complex systems. And how do we think about the whole distribution as an outcome of a complex process, rather than just trying to identify some sort of an outlier or some sort of single phenomena? It's not the leverage point that system interventions will be effective at. So Stephen, and then any other raised hands.
This also ties in, I think, nicely with the idea of post-normal science. The idea that in the post-normal science world, where you in high levels of uncertainty, you have to make decisions. So COVID is a classic case, right? They had to make choices in January, February, March, April, even now, and you don't have the data, right? You don't know. Right. And in the same way with active inference, the brain and different parts of the body are making action policy selections as is going to inform action. And that's not quite the normal realm of where science is. You're in this, but this is where we're going to be going as we hit climate change and all sorts of other complex questions. So that also is quite an interesting tie-in, because Tristan, I don't know if you know, but he did some modeling on COVID-19 as well. Yeah. So he's got into that.
Yeah, John, maybe you could unpack that in the context of second order science, which you discussed in the papers.
Or maybe I can just pass it to Lee and he can say a few words.
Yeah, Lee.
He's the expert here. No?
I know, I'm happy to. The concept of second order science really is just that the idea that the scientist can't be separated from the systems that they are studying. So really, where that's kind of led to in systems transformation research is that the only way that we can really understand systems is by engaging with them and learning how to change them ourselves. So we can't kind of stand back and just try and focus on epistemic knowledge alone, really. And that also implies this kind of second order understanding of ourselves and how our own cognitive systems work as part of the systems that we are engaging with.
Yeah,
I hope that was
value-driven science, where the scientist is part of the experiment with the stakeholders. Absolutely. Hey, Lee, while we have you here, that paper by Faizi was authored by a very large number of people, it seemed. And can you just say if you know the story behind that?
Well, a little bit. I think it was authored before I started studying with him, but there's a transformation community, really, I guess, of researchers, and I think it probably came out of one of the conferences that's been going on. So it's sort of the product of a discussion between many researchers, which is the way that they kind of prefer to write, really. So again, like moving away from this idea of the single genius to let's kind of get together and figure this stuff out together.
Right. I reference Faizi's paper several times in my part number 2, so readers can see how that fits into the bigger picture here.
And it's funny that idea that the product of research is collaborative. It's a colony phenotype. It's a group phenotype. How well this paper is, and how many people cite it, and how much impact it have. It's not going to be reduced back down to a single person. And so let's take that, and then just like you brought up, Lee, the implications of learn by doing is that we have to infer by acting, basically. So then what does it mean for the scientist who's all in on that to be studying climate change on a coast, or the conservation of a forest, or sociology or anthropology? Very interesting questions that I hope a lot of different listeners can see resonating with their own situation. So Stephen, and then any other raised hands.
I think just also building on the idea of this distributed input is, and in many cases, it may end up that a lot of the work is not in science anymore. It's like science-informed development, or science-informed, or even science informing a model, and the model informs practices which inform the way that communities can get involved. So now the real agent is actually the community, and we're serving them. So this interesting shift between where science fits in and can change, I think that's quite interesting as well.
Yeah. I could have titled the entire series "Science Influenced the Transformation," because that is the concept I was going for. I called it science driven, but my idea there was similar.
And also the historical perspective, which includes many world knowledge traditions and hundreds and thousands of years and multiple continents, not just the story of Western academia, understanding that has not been a steady state. There's no stationarity with peer review. Again, mainstream science, especially the second half of the 1900s and further, that's new. So science is in transformation and has always been in dialogue from 10,000 years ago. So now, given the agency that we have and who we are and our affordances, our preferences, what's the move? So we don't have any sort of a locked in phase to resist against. That's not to say there's not inertia, but it is to say that there's actually a lot of agility in the system. The question is, what are the leverage points where we can actually make that impact, and how might active inference come into play?
Maybe since we're on the topic, maybe we can just jump ahead just a little bit, if I can find it.
You find the slide, or you find the slide, and then Lee, go for it. Go ahead, Lee.
Just to pick up on your point there, Daniel, really, I mean, I've kind of been hesitant to say it, in the active inference kind of Discord server and the like, but I see such a huge amount of emphasis on active inference as a means to to create AI and to improve AI, and I can't help. I mean, I really spend a lot of time thinking about how can this knowledge be used to improve our own individual cognition and societal cognition, human cognition, really as well. There doesn't seem to be. I mean, maybe I'm just missing some of the literature on that. So if there is any, point me towards it. But it it really seems to be that, like the big assumption is, we got to put this stuff in AI because that's where all the progress is going to be, et cetera, et cetera. And I kind of wonder, is that really a wise goal? I don't know.
I think active inference and several other paths, so not exclusive to active inference, it rethinks part of artificial intelligence because it's part of our extended niche. And so, yes, there's been a lot of focus on applying active inference to machine learning and to reinforcement learning, those types of areas. And then what we're talking towards here is the integration of natural and artificial intelligence under a broader extended cognitive systems scope. So humans in the loop or real-time computers, just like every stoplight or every bank transaction is going to be, every tweet is going to be, designing those interfaces so that within each blanket, there's functional cognition, not viewed only from the outside in, but as part of a broader system. And maybe we find out that we had good enough artificial intelligence, so-called algorithms, in 2004, and that we just had to hook them up in a different way. Just like connecting different parts of piping could give you an engine that's more or less efficient. Maybe it wasn't the case that we needed some sort of scaling on a larger data set, but we needed a new way to combine subcomponents, which is what biology does as well. So, yeah, John?
Excellent stuff.
Yeah.
Just a few more thoughts on that. So the science world and particularly this cognitive framework or concept of what is cognition, I think can be useful both at the societal level and at the individual level. I mean, in the sense that if science can help direct the attention of the world to how intelligence happens all around us in nature, all around us every day, how we evolve to expand on the information process and the information processing, the capacity for information processing. So it helps it just helps an individual to understand a little better, or have a different perspective on what am I doing? Why am I here? What am I doing? Why am I? What am I? To a degree that these new developments in cognitive science can help to shed some light on questions like that. And at the same time, for a society, like, what are we doing here together? What is our purpose together, right? Yeah. And if you know your purpose, it's a lot easier to know where to go next, how to frame things in a way that is suitable for your continued well-being.
And it's a bright line in some senses between first and second order science. In the first order science literature, there might be a lot of sort of engineering type appeals to, well, we'll make the society more efficient, or science informed policy will just simply be better. And once we take that second order turn, we start to think we're going to have increased clarity about our values. It's not going to be an easy conversation. We might need to invent new ways of having the conversation or formalizing our values, but we need some sort of path that's going to bring us closer to clarity on our values rather than obscuring it with technical advances. So Stephen, or John, go ahead, and then Stephen.
I was just going to say obscuring it with technical details, but also obscuring it with incompatibilities between what the science world is saying and doing and what, say, the governance world is saying and doing, or the economic world is saying and doing. Obviously, if all of these systems are part of the cognitive architecture, you want to design them so that they are integrated with each other, so that the signals travel from one to the next, just as the signals in your body travel from one system to the next system.
Yep, Stephen?
And I think this also ties into partly what this lab has been talking about quite a lot in trying to enable this possibility of making those transitions without losing the rigor of the modeling, because the modeling is seen as almost another way to get at empirical data. It's not quite the same as science, but the challenge you have as things, unlike traditional science going towards engineering, you do have this ability to embrace affect and values, but the challenge is how to stop things getting prematurely reified, How it's so easy, things get reified, and suddenly, effectively, you're just using another word for system boundary, and you're kind of really doing the same paradigm work with some different window dressing, right? So it's really, that's the challenge, I think, to and I don't think anyone's quite managed to do that yet, but I think that's definitely...
No, we're on the cusp. This is happening, right now. This struggle of what does it mean and how do we do it?
And the premature reification, as you said, Stephen, it's basically, there's a perfect investing strategy. If you had the time machine, you'd know exactly when to buy the dip, sell high. We don't have that. We're moving forward. We don't have access to the future. So there's two kinds of confidence errors. There would be being overly confident, so too early zoning in on a solution. That's the premature reification. And the other fallacy, or the other side of that perfect strategy, would be waiting too long. And so somewhere between waiting too long and acting too fast is that trade-off space that we have from so many different perspectives, with not just finding the value of explore versus exploit that's going to be best, but rethinking the explore and exploit outcomes as part of a process that might be doing something like balancing epistemic and pragmatic value, for example, in the free energy principle. So it's a really awesome conversation. And John, continue.
Yeah, and altering how you measure fitness relative to those two differences. Well, since we've been talking about science, the role of science in this, why don't we jump ahead to slide 2, Jamboard 2, slide 16, if you would.
Yep, I'm there.
And okay, that's fast. And while we get that rolling, just one more thought on second order versus first order science. Faisy's paper is great, really, I think, an important one, but it's new. I mean, it's new to the science world. Most of the science world is very focused on what we would call first order science, where the scientist is an observer of a system, not engaged with transformation of that system or achieving value-driven goals in that system. And first order science is fantastic. We have learned a tremendous amount of knowledge, gained a tremendous amount of knowledge from first order science. So it is fantastic for what it is, and has to be continued. But in addition to that, we can also start to be thinking about what is second order science. How can the science world be engaged in a value-driven effort towards some better future? And I suspect that there are lots of scientists who are frustrated because they don't know how to. There's not an avenue for them to participate in really jumping in to make this world a better place. Intelligent people look at our world and they see the enormous stress that we're under in this moment, and are fearful of the even larger stress that is likely about to befall us. So I think that there might be a tremendous amount of frustration in the science world of how do we use our capacities to actually fundamentally make things better, as opposed to just passing off sort of trivializing it a bit here, but just passing off a recommendation to some policymakers who then do whatever they do, and the scientist is then out of the loop. So I think that this is the time for second order science to flourish. This is the opportunity for the science community to really get engaged in these deep and important problems that civilization faces right now. And in the series, I'm trying to propose an R&D program that is a path for the science world to get involved in these deeper questions and have a deeper impact on civilization. So this slide is kind of a summary of from my paper of why should science care about this, and why should science get involved. And we can talk about any number of these, but I'll just sort of jump through them a little bit just to highlight a few ideas. The very first one is just this idea of societal cognition. That's kind of new. There's great potential for scientific discovery just on that question of what does a society cognate? How does it cognate? In what ways, by what mechanisms, by what features, with what characteristics. I mean, there's, just as far as expanding the level of knowledge, this question is really interesting. The second one, so we're talking about designing societal systems, and obviously this is a really complex issue. This is not a simple, how do you build a better can opener, right? This is difficult and complex issues, and the science world has skills that can be really useful in addressing these questions and framing the movement towards how do we start, how do we test, how do we measure fitness, what is the goal? What is the purpose? What are we doing? Like the science world would have a lot to say about framing this entire question of what is societal transformation and how would we move forward with it. I might add to this that, as I see it at least, one of the benefits of having the science world involved in this question of societal transformation is that the science world can provide kind of objective and consistent metrics and frameworks to help guide the process. That is, turned around, if this process of societal transformation, this program of societal transformation, was merely based on what a group this group votes for this, let's do this, and this other group votes for let's do this, and it was just a popularity contest of whatever was most popular in the moment. That's where transformation is going. I don't think the science world would have much interest in that, like popularity contests or that kind of effort. Where's the knowledge in that? Where's the science in that? It would be, on the other hand, I think it would be very interesting to the science world if transformation was based on some kind of principled approach, some kind like we can agree to an extent, at least, we can agree what fitness might mean for society. And some of that would be based on objective measures, some of it might be based on subjective measures, but intelligent people can get together and conceptualize what fitness for a society or for a societal system might look like. These are, of course, complicated problems, deep problems. But if we could do that as a community, if we could find some way to assess fitness in a reasonable way, a reasonably coherent way, a reasonably consistent way, then we have a path to move forward of, different groups could try different ways to reach a high fitness. And all of those experiments would be adding to the body of knowledge of how do we do this so that fitness improves, right? I don't mean to say that coming up with fitness scores and fitness evaluations of new systems would be easy, but it is a topic that we can tackle, and it's because of our capacity to conceptualize fitness and formalize fitness in the sense of a formal assessment. I think that makes the whole I'm hoping that makes the whole project interesting to the science world, because now this is science. Now this is expanding knowledge. This is using first principles and scientific principles to evaluate systems, and it's not a popularity contest. It's not this is adding to our understanding of how the world works and how intelligence works and how cognition works, and expanding it out to the societal level.
Thanks.
So I don't know. Maybe there's some thoughts on that alone. But.
Yep, Stephen, and then anyone else who raises their hand.
Yeah, just sort of a couple of questions around the idea of fitness landscapes and how that might be used. Is I sense you're sort of proposing that you could use these kind of fitness landscape, I suppose you could even have descent on free energy landscapes, to try and help inform policy selection, i.e. maybe which research streams you're going to go down. Because at the moment, we're kind of either tied into what the market says or some other methods, but this could, because this fitness, maybe you could sort of separate out, because I could see a couple of different ways you could look at that then. Is it like an extra field of practice to inform choosing the policy of which research field to go down and which avenues, or is it also within the field? Is it with the fields connecting to each other? I just wondered how that might be.
It's all of those, because everything that we do ought to be serving our purpose. I don't. Obviously, there's great room for play and and exploration and all that kind of stuff. I don't mean to make humans two-dimensional or something. Humans are complex organisms. They have complex needs, and all of those needs must be addressed, right? But the fitness, the concept of fitness, I see that as permeating multiple levels, right? Because yes, we would want to choose policies that help us, and then what does help mean? What does it mean? How does it look if it helps us? What is that all about, right? That's so, in some sense, if we just say I want to help, we're already thinking I want to improve fitness somehow, right? But not just policy, but even structural design of what is a system? How does society make decisions? How do we communicate? What is our communication systems? How do we get input from everyone into this process of decision making? So across the board, both in the structural design of systems and institutions, and even to some degree social norms, right? Through education systems, like what kinds of social norms help us, and then obviously too, then in policy, but then even in our individual lives, like it helps. I think it might help individuals to understand that what we want is improved quality of life, lower uncertainty. How can I make decisions in my own life that bring me the things that I think might actually make me feel better, that actually might serve me on a even a superficial and deep level, right?
Thanks, John. Lee, and then Stephen.
Yeah, just some thoughts on the fitness metrics, really. So, and this kind of goes to the point about the way that scientists need to engage with local communities, because there's quite a lot of work that's already starting in that area, and a lot of it is based around this idea of place. So scale is already being taken into account, and there's this whole kind of sense of the emerging bioregional movement, which just essentially means aligning your political and governance boundaries with the boundaries of ecosystems. And that then naturally has the effect of it partitions things in a way that's meaningful to local people. And then you can start to ask them, like, what is it that they value within their place, because they're already kind of connected to it in a way. And I mean, I suppose one thing for me is this idea of metrics really versus counterfactual simulation, because once you start putting a metric on something, like you have a number, and then that's something that people can't really care about. Whereas like if they can imagine how their local river system, for example, wouldn't be polluted by sewage being released from the sewage works, or runoff from the and they could see that then has the sort of the effect of of engaging people, I think, more in the actions that we would need to collaboratively take to make these kind of things happen.
Sure, sure. Different people might react in different ways. To some people might be more, really appreciate the modeling aspect. Other people might just appreciate the boots on the ground, local change aspect. But I would say there's room for all of that. And the bioregionalism concepts are great. I've been a fan for a long time. And who knows, maybe in the future we'll move more and more towards that, so that communities are really localized in their environment and protecting their environment and all that kind of stuff. That's great. In some ways, science has to catch up with communities of change who have been working on this for a long time, these concepts. And in other ways, science is already, pulling communities, helping to say there's more we can do. There's a bigger picture we can serve here. So it'll be a give and take, I think, between communities. And just one more thing is the bioregionalism idea is great. And a lot of work also has been done in alternatives to GDP. So, the metrics that people are talking about, considering education and longevity and disease and all these other things as opposed to just a single GDP measure of societal quality. So there's lots of work being done on multiple fields.
And to speak to the metrics from an active inference perspective, let's just say that we wanted a river that was unpolluted. We wanted no toxins in the river. So our preference in the active inference model would be that the river is clean. That'd be in our preference vector. Now, traditional reinforcement learning would look at the level and it would reinforce policies that reduce pollution locally, and then it would forget policies that didn't locally. Now, the question is, let's just say you start decreasing it and all of a sudden it starts creeping back up. Your reinforcement learner is going to be quite confused. So in active inference, we can say that our metric is actually our uncertainty around our generative model of the river's pollution. So then what actions can we take if our uncertainty starts to get wider? How can we increase our precision on our generative model of pollution? And then, of course, concordantly with our values that it be unpolluted, how can we act to reduce our uncertainty? And so it's the reinforcement, economic maximization mindset. Pick the metric. I want everyone to read. That's the metric. Reading. Well, no, the preference is that everyone can read. But the metric in active inference is our uncertainty around our observations. And it's an extremely subtle at first, but eventually very far-reaching way to think about these systems and what fitness is. Because a lot of times, fitness metrics, people are going to be thinking, right, like GDP, or right, like something that we want to see. But we can actually now tease apart our preferences from our affordances, from our uncertainty in our generative model, and several other features of active inference scale-free models. And that is going to help us have a multi-stakeholder conversation in a new way. So,
that's great. Great.
Thank you, John.
I just add to that. I totally agree with what Daniel just mentioned there, because it's not an active inference per se on its own, but it's the ability of active inference to be used in this epistemic foraging way. And I think the point that was made there about reinforcement learning, which we kind of think, oh, that's some machine learning method, but actually reinforcement learning is the dominant approach to development. It's the way humans have structured in a way their own thinking. It's not exactly reinforcement learning in such a bit, but it's so constrained and it's so goal driven. And the only integrating way to overcome it, and why Thatcher then started saying there is no alternative, is the market. It's saying it can't deal with the complexity beyond a certain point, so you have to offload it to this market, which again, you get into that kind of just becomes whatever's the favorite of the day. And this gives us a way to get into this nuanced complexity, gives us at least the chance to go some other route and plausibly deliver on that promise. I think that's really cool.
It's
right. Absolutely. Go ahead.
To give like a spatial metaphor on reinforcement learning versus active inference, it's like if there's a mountain peak that we know that we want to get to, the reinforcement learner would say, okay, the goal and the reward is the elevation. And so it can get trapped on a local elevation peak, but then it might not take a step backwards or down a few to get to the highest peak. But again, if we do a trajectory of policy inference on getting to the top of a mountain, again, of course, as a preference that we have for ourselves in the future, we can ask, am I reducing my uncertainty about how I'm going to get there, when I'm going to get there, and the way that we're going to do it together with potentially a group of hikers who have different capacities, instead of how are we going to get to the top of a little knoll and then just stake out. So it's a different conversation style. Stephen, and then anyone else.
Yeah, and sort of building on that is when you have that come into play is the ability for the active inference approaches like you're talking about is magnified greatly when you don't just focus on the one person or the two people who are like the agents of change, but you say, well, what about the local people who have no idea about the goal? They have no ability to elevate. They have no ability to contribute to the reinforcement learning, but they know the slopes. They can tell me the history. They can tell me where people fell to their death in the past, or where there's, you know, all these, and that then makes the place-based, community-based contributions much more plausible as why they enable the scientists and other people to do exactly what you were talking about. Yeah.
Excellent. Just to point out, so we're talking about reducing expected uncertainty about the future, right? Think of all the ways think of all the implications of that in, say, design of systems or design of institutions or actions of humans, facing some problem, right? So one question that immediately arises is, do we have enough information? Are we collecting the right information at the right frequency to even understand what's going on or to reduce our uncertainty? Second is, how good are we at anticipating the future? Can we do that with some accuracy? Do we know what's going to happen next? Do we have any idea what's going to happen next? How good are our worldview concepts that lead to anticipation of the future, and how good are our computational models about what's going to happen next? How good is our information sharing capacities? How are we communicating with each other? Are we communicating the information between groups and between individuals such that we can understand what's going to happen next and understand what our uncertainty levels are? I could go on, but there's like this, it seems like a simple proposition at first, and then you realize that proposition has enormous depth. It implies all kinds of things about how a society might function and organize itself.
One thought on the wisdom of crowds and distributed computation. There's a famous example from early in quantitative genetics where it was at a World's Fair and a crowd was asked, you put in a raffle ticket and you can predict how much some cow weighs. And then the average of the estimates was extremely accurate, although many individuals were, of course, distantly off the mark. And a lot of people take that just straightforwardly as existence of the wisdom of crowds. But there's a few pieces of that scenario that really matter. The first is that the people attending may have had experience. They may have been working in agricultural settings or have experience with getting feedback on their predictions. And secondly, the estimate was a bit bounded. It wasn't that the cow was 1 pound or 10,000 pounds. There was an estimator. And then it was still a cognitive diversity that contributed to that estimate. So you couldn't just look at somebody who overestimated and said, well, we'll get rid of that guy, he's wrong. It's like, that's counterbalanced by someone on the other side of that curve. That's how we're getting an estimate. So having a distributional and a community perspective on decision-making helps us recognize and encourage and foster diversity of opinion and also structure a resilient community. So it's something that will be really interesting to see how and where these kinds of memes and ideas pop up.
Yeah, absolutely. Valuing differences of opinion, valuing differences of perspective is one thing that you had said there. Just add something to that is in our polarized society today, there's like liberals and there's conservatives, at least in the U.S. And they seem to be in two different universes almost, right? But liberal and conservative, at their best, is a little bit like exploration versus exploitation, the necessary balance for any organism or for any decision-making process to balance exploration of the unknown and exploitation of what is already known, what is traditional, what is our history, what do we know works. Like at their best, liberal and conservatism are both important. They're just as exploration and exploitation are both important in problem solving.
And they're relative, just like left and right.
And relative, yeah.
When you're spinning around and things are changing, it's hard to say. And that's why we can pull back to some real pillars of biological systems instead of trying to scaffold further and further into the political or the logistical ether. We can actually return to our grounding as a biological society. So Lee, I saw your hand raised, or maybe I didn't, or Stephen. Oh yeah, Stephen, and then anyone else who raised their hands.
That was quite interesting. You made that point there about, we look to explore the unknown. And I think that in addition to that, because that's from the perspective of, say, the scientist or the person in the kind of the knowledge generating game, so to speak, that's their profession or whatever. But there's also the exploring the known, but not known that it's known, the tacit, so this is where communities can come in, is like, there's like by realizing that some of that unknown is participants in those environments know, it just needs to be surfaced. This is where some of the work with the environment side of the active inference, the niche, and these topographies that I'm quite interested in my side, can come in, because now they're exploring and revealing stuff, and in a way which is networked and sort of not just isolated as single stories or experiences and fragmented. So I think that connects with what you're saying.
Can you give one example of what you're thinking?
So one example, we did a project around water issues in rural areas of northern Maputoland in South Africa, and so they had different areas of water catchment. So some people were getting water from a lake, but the lake had hippos and crocodiles, so it was a bit challenging for them in different ways. And so you've got these different water catchment areas, and it's like they had the lived experience of having to go there, having to get the water, having to boil it, because if the water's contaminated, you've got to boil it. And there's other what it means then if you're then doing that, if you've got someone at home who's got HIV on top of that, so then so they can't walk, or they've got to have, so all these questions. So what they would do is they would create a fabric map the size of the room about all their different routes to water, and then share the stories from 8 different or whatever numbers of hotspots, and then that became the sort of landscape. So in doing so, that wasn't given the answers, but it was informing another process maybe a week later, which was looking for innovations, looking for options for new approaches. So that's one type of way that you could like reveal something from the local landscape which would never have been available to an engineer from their own knowledge.
Yeah, great stuff. So some of what you're talking about is what is our narrative, what is our individual narrative, and what is our shared narrative, right? Like what is our life, what is our experience of life, and what do I as an individual have, what knowledge and lived experience can I offer to this group that would help the group to eventually function better or make better decisions, right? So that's a really interesting question to me for many reasons, but one reason is suppose we were to move forward with this whole project was moving forward. How do we communicate with each other richly? I would argue that there is no system, no functional system right now that 1 million people or 10,000 people can richly communicate their lived experience, their understanding of life, their understanding of what might happen if A, B, and C happen. I don't think we have we're in need of tools to richly communicate. We're in need of tools. Yeah. So that's an immediate opportunity for groups to get involved with, is just that little question of how would we communicate, and how would we would we make decisions together in some kind of collaborative fashion? How do 10,000 people do that at once, or 1,000,000 people? When you can't all fit in a room, that's the question. When you can't all fit in a room to really thoroughly discuss these issues and listen to each other, how do we do that at scale?
Great.
So
Great
that is,
question, John. and
I think there could be answers to that. That's not an impossible task. That's a really interesting and doable task if we just put our minds to it. Go ahead.
It's related to regimes of attention and active inference perspectives on narratives, which were even our first ActInf live stream. Number 1 was on narrative active inference, because we think it's crucial. And if there's going to be a social narrative like you had brought up, well, that's something that is not just sharded into a person's brain. It's not a holograph where it's the same in the person's brain as it is at the social level. Things that brains know that neurons don't. It's not like each neuron is holding a little mini brain. It's actually that there is differences amongst neurons. Or if you think about like Star Wars or a movie, it's like each character doesn't know the whole omniscient scope. And so we're part of a bigger story. And so it's going to be interesting to explore what will it feel like as a person, and what will it be like experientially with a personal narrative to be part of a broader societal narrative, but those will not be the same thing. And the desire for those to be the same thing will lead to system fragility in many cases. So Stephen, and then any other comments?
Yeah, I think that ability to know certain things is a very important point. And I think in active inference, something that I've increasingly been looking at is we've got external states and we've got hidden states, okay, in different ways. So there's, from the perspective of the generative model of, say, a water engineer, there will be more, like there's hidden states from everything, right, from everyone to some extent, okay, as well as states that we can engage in. And so there will be this question about how do you engage the hidden states in a landscape, as well as the external states of the regime of attention, and where can someone else who's got a different lived experience contribute to opening up and maybe telling us where they think the meaningful aspects of their landscape are. So that I think that as well as modeling happening from our own computational models and being able to maybe use some tools, we can model through participation in place-based.
Absolutely. So this tool I have in mind, I want to have my voice heard. I have a story that could be important to others, that could be important to any particular situation or topic that society is trying to decide upon. And I would very much like my voice to be heard, and not just a yes or no, or not just a choose A, B, or C way. I have a rich experience that I want to communicate. Now, another person sitting next to me might have a model of water quality or whatever the issue is, and they might have something to say about what their model implies. But all of those voices, right, should be heard. All of those voices should be part of the cognitive process of a society. So certainly data-driven, formal models of this and that. Sure, that's great. That's fantastic. It's an extension of our cognitive capacity, and at the same time, I'm intelligent, and I can do things a computer can't. At least today, I can do many things a computer can't. So whatever communication system and process that develops out of this ought to be one where every voice can be heard, can be registered, can be incorporated into this larger, really cognitive process. You're talking about it's like sharing and we're discussing, but that's a cognitive process, right, for a group, because it's leading towards some better understanding of the world and improved decision making about the world.
John, if I could, you mentioned data-driven. So to, again, sort of distinguish and contrast with how you're potentially using data-driven versus how it might be implicitly used in other settings. Data-driven, who's being driven? Us. The data are driving us in our policy. Oh, the policy is going to be data-driven. Okay. Well, how about it's human-driven? How about the policy and our affordances and the data are like a car, and we're driving the car? Do we need a better car? Does it have too many wheels? Where are we driving? Whose turn is it to drive? How are we choosing which music is being played in our human-driven car? Not how are we going to fit into a data-driven human mode? And it's just interesting that sometimes what is left unsaid or unstated is where a lot of those values get swept under the rug. It's data-driven. What else do you want to talk about? Oh, values? Okay, well, there's time for values. It's like, there has to be time for values, but the data-driven conversation makes it sound like it's the beginning and the end.
Right, right. Today, yes, yes, and I think that can be expanded greatly. Right, so that's when I use the word richness. That's a little bit of what I'm trying to imply is the richness of experience, the richness of perspectives, the richness of past information that I as an individual can bring to bear on this issue, whatever the issue is. And then on top of that, what does the data, what data do we have? How frequently do we collect it? What is its quality? How can it contribute to this discussion? Right. So very much it's not that the computer has to decide what to do, it's that human beings have to decide, what to do. Given all this information, what do we do? How do we frame this? How do we frame our problem? Are we even looking at the right problem? Is our focus too narrow? Or do we need to broaden our focus to understand better how all of these different problems? So very much human in the center computation.
And to connect that to first and higher order science, and I'd be curious, Lee, what you think. The first order project is like build a bridge. The second order project is like, given what needs to happen, is a bridge the best solution? Or maybe we can go about it a different way. And the third order is, well, what really needs to be done here? What do we value? Who are we? Those types of third order questions, which potentially even are on an escape trajectory from science, because we're not going to be looking to science in a narrow sense for the answer to that third order, truly human question. But we do need to expand this discussion from what is the best way to build a bridge to how are we going to go about fulfilling transporting people from side to side or making a landmark for our city. There's different reasons why we might want to build a bridge, and people feel like a cog in the machine if they're just being instructed at the first order, like do this.
Right.
But when we're including people in higher orders, then we're part of a multi-scale cognitive system. We're not just a, quote, cog in a machine.
Right.
So Lee, and then anyone else.
Yeah, I think this is a really important point, and for me, it touches on Metzinger's transparency, opacity kind of. Do we understand the beliefs and the frames consciously that we're operating out of? So in the bridge metaphor, you might say, at the third level, the third order, it's really about how are we looking, what's the ontology or the set of metaphors that we're even coming at this system through, and what effect are they having in shaping, how we perceive it, and B, then our actions towards it. So, going right back to the beginning of this discussion, it was quite interesting when Stephen asked you, John, about architecture, and I'm kind of thinking, is that a metaphor? The architecture of the brain, is that a way of looking at a brain, or is it something? This parallels the discussions about Markov blankets, etc., etc. Are these things that we're imposing on systems, or are they things that are really there? I think the architecture one is really interesting because it kind of comes from this, whole constructivist tradition, and I wonder more whether it's not so much whether it's about the right, or the most accurate way of seeing, but what particular set of affordances does a model or a way of seeing offer us, in the face of this particular problem in this particular niche, perhaps. So yeah, interesting stuff.
Thank you, Lee. John, continue, or Stephen, and then John, feel free to continue.
Yeah, just one last piece. I think that there's some areas that I'm trying to apply these isms now to sort of put some buckets on. But I think the social constructivism is an important one to think about. And maybe science, in a way, kind of fits in that in a way as a human pursuit. Pragmatism, I think, is very well aligned with the kind of approach of active inference and this approach here. If you take pragmatism from a not a humanistic perspective, from the third one, which is an ecological perspective. So or any ways of knowing as well, not even perspectives. So you can drop down into ways of knowing, perspectives, pragmatism, social constructivism, and ecological approaches. And I think that nexus is quite important to as a sort of way to hold some of these ideas.
Yeah, this is a fantastic conversation, and I would say that exactly the kind of conversation that would be needed to move such a project forward. It would be conversations like this, between scientists, within the communities, between communities, touching on all these, some superficial and some very deep and subtle issues and questions of what are we thinking? How do we do this? How do we measure success? What do we want? What is our purpose? I mean, we're just maybe starting that conversation here amongst us, but I would like to offer to the science world that this could be, a function in the science world of, a pursuit of study, a pursuit of attention. And if it were, I think that I think that's all that's really necessary, actually, is to put our minds to this, and intelligent people communicating amongst themselves and engaging all interested stakeholders could definitely make progress in this endeavor. So great to watch, great to be a part of.
And also, yeah, John, maybe if you want to go to another slide, but that's leading to the question: how do we, in our .1 video? It's kind of an opening. The .1 is where we've had our background with the .0s. We've hopefully read the papers and digested them, written comments, written thoughts to ourselves, allowed that to reverberate. And then we open the doors and we come together in a group discussion for point 1. And we also say, hey, the doors aren't closed. More people can join this conversation, whether it's next week for point 2 or on a broader scale. So I'm just wondering whether you answer now or later, who can be included and how can they be included in participating?
Right. Well, I can say a few words. Everyone is welcome in this conversation. In the world, in communities, in different types of communities, the science community, other communities. I mean, this is a conversation for all of us to be had. What do we want? What is our purpose? What are we doing? How can we improve? How can we reduce uncertainty? About essential variables. To put it more technically. How to do that? I don't know. I'm open to suggestions of how we make the next step. I sort of put out what I could put out in this series, and I'm hoping that these conversations might lead to some actions that engage a larger and larger sphere of individuals and organizations. So I'm open. If there's suggestions, I'm open. Could you flip to, let's see, that would be slide 2, talk 2, slide 8.
Yep, go for it.
So we've touched on all these ideas, and I thought maybe this might be a good moment to talk about some of the practical implications. When in our original discussions, this slide was coming after paper 1, which was all about worldview and seeing life as a cognitive process and seeing individuals as overlapping processes of information flow, and understanding that when we talk about a community improving its quality of life and quality of environment, we're talking about an extended individual and an extended community that really reaches all the way to the biosphere ultimately, right? We're all connected with other individuals, and all communities are connected with other communities, and all of life is connected. We're connected with our local ecosystem and with distant ecosystems. So when I talk about vitality, I'm talking about the vitality of the whole, really. That's our purpose is of human. We're intelligent. Humans are very intelligent. We can think 1,000 years into the future of what might happen if we do something today. And humans can use that capacity to improve and reduce the uncertainty, of the whole. Improve quality of life, improve the quality of the environment and biodiversity and all that kind of stuff. So with that kind of theoretical aspects in the past, what are some of the practical implications? Like how would we use any of that information to actually think about design for societal systems, right? So, so this is a list of some items that we have talked about in previous talks and even touched on today. And when we think about what does this mean practically, I would like to focus that to a different question, really, and that is how does any individual, any organism solve a problem? Like what is necessary to solve a problem, whether you're a bacteria or you're a human community, right? What do you do? And on the left are, I would say, some of the universal aspects of cognition. For example, you have to gather data. I mean, the intelligent being is processing information, and information means that some kind of data or information has to come from the world, and then it can be processed. It has to remember, for example. It has to anticipate the future, forecast the future with some accuracy in order to survive. If I see if I see a lion in my path, I might want to accurately forecast that if I don't get out of the way, I might be the lion's dinner, right? I mean, anticipation is central to cognition. So I've only talked about the first three in the list there, but already we could talk about what does that mean for a community then? So how does a community gather data, for example? And that might be, through sensors, through getting the input of others in the community about some particular issue. It requires remembering requires that information be kept in some kind of accessible form, some kind of repository of information. We can think already of ways that society does these now. We, for example, the Census Bureau collects information, annually and every 10 years, collects various kinds of information. There's financial surveys done every few years. Some of that information is put in repositories that at least researchers can access for different reasons. But how would that differ? How does what we do today, how might that differ from if we were really thinking of communities as cognitive organisms? How might we improve on any of these processes, right? I don't know if there's thoughts on that, but I can.
Yeah, Stephen, go ahead.
Yeah, I mean, one thing I think that's interesting is this actually points as well, though, to an interesting dilemma. I don't know if it's a dilemma, but certainly a challenge in the sense that these artifacts of knowledge that we have, they're we have the option in a community setting to place them in our environment because they can be equilibrium based artifacts. So for instance, if I create a book and I put it on a shelf, it could be there 100 years, right? And I come back and it's still a book, right? So you've got this ability for that kind of storage. Now, when I remember something, I'm with active inference, I'm establishing this kind of priors, an update of priors that is generated on these lower level sensory flux pieces of sensorum, which I have at higher levels potentially started to interpret as what you might call a signal. But we get into this interesting question because it's like the error is kind of the signal in active inference, although it's possibly at higher levels of thinking it gets a little bit different because we've been talking about that with some of the modeling. But there's an interesting question around as you scale out where some of this sense data in active inference is kind of held in the kind of collective knowing of a community, which knows how to interact, for instance, with the artifacts. yet you've also got aspects, a bit like I've got my clothes and I've got other things that are kind of, are they part of me? Are they not part of me? Are they part of the environment? So I think there's something quite interesting, and I think that's an area I'm really interested in exploring, is teasing that out. So I wonder what your thoughts are on that.
Well, I think part of what you're speaking about might be what I've been calling richness of information, right? So obviously a census can collect information once a year about, numbers and education levels and things like that. That's one stream of information, a valid stream of information. And yet another is very personal. It's what is your gut, what is your gut telling you about this situation, or this constellation of what's happening today? What is your gut feeling of what's happening, right? So how does a community process, sense and process all of that information together? If you have if we're a part of a community and we're trying to decide on some issue, it would be good if we heard your gut. What is your gut telling you about this? Is this good or bad, or is this direction good or bad? Or even if there's no like data to back it up, what is your sense based on your complexity, your wholeness, we can't even put a word on it what you are or where that information comes from maybe, but what is the sense that you're having? And I would like to share my sense too. And everyone maybe could share their sense. So how do we do that when there's 100,000 of us? How do we do that?
Well, to give just a few thoughts, there's two sides to the conversation. There's sharing, communicating, and then there's really engaging and listening, which is part of the regime of attention topic. So 100,000 people speaking over each other is zero conversation.
That's not. That's not conversation, right? Exactly. Yeah. So how do we do that? And I don't think that's not, it's almost surprising in a way that we have such enormous technical capacity in today's society to do unbelievable things, and yet this very basic question of how do we, as a community of say 10,000 or 100,000, how do we richly share information in a way that all of us feels heard, that we can express our kind of like hard knowledge and gut knowledge? How do we participate together in describing our situation, describing our fears, describing our uncertainty, anticipating what is going to happen next if we take choice A, B, or C? It's kind of interesting that tool doesn't exist in spite of our technological process. And there might be reasons why there might be political reasons and economic reasons why that tool doesn't exist, because if that tool did exist, people would want to participate, naturally, I want my story heard. I want my community to understand what I know, because maybe it's going to help somebody. And I want to hear what in a healthy conversation, in a healthy exchange, I really want to know what you're thinking, and I want to contextualize all this information in light of what our purpose is, what our goal is, what are we after, what do we want, right?
Yeah, can I comment on that, because I think this is a really important point, and also though, as well as this is what I find. I'm recasting speech as an action policy, as an extended cognition into a spatial landscape of semantics, right? So effectively it's actually words could be seen as in a virtual environment that we're projecting out. And what that can kind of open up is that when I'm talking to someone and being heard, right, which basically means words are being heard, right? So, but there's certain things that I can't communicate through words because they're not in that semantic landscape, which is the compression of a useful tool. But the thing with tools is, generally speaking, it's not very healthy to relate to tools, right? It's like tools are things. So non-verbal work can be really powerful. And we actually had that with our work with the community who use alternative communication. We really pushed that. So it can take them 3 minutes to do 3 words, because if they're using a head switch and they have to scan through each letter and then hit the head switch and then do. So we're really about how about it not being about the words and it about being the look of the eye, and that building up of non-verbal knowing between people, which at some point will probably be, well, we actually then articulate that through fabric landscapes. So then they start painting the room and do world building, and then you start making the words. So there's something about, like you said, there may be something that we need the tools, but also sometimes tools just can't go there. So what do we do where we don't use tools? And then when do we bring it into a tool-based environment? I think this is a good point.
Yeah. And I think much of human communication actually happens non-verbally too. If we can be in the same room and I'm watching your facial expressions, I'm getting a lot more information about you and your intent than if I was only hearing your voice, if I was only reading your words. So sure, there's nonverbal communication, there's artistic expression, there's poetic expression, using words in a different way, and obviously we as an individual, I want to be heard. And if maybe I'm expressing myself in words, maybe I'm expressing myself in how I'm raising my eyebrows, or maybe maybe I don't even have words to express myself, but I have an image in my head that I want to communicate. Somehow we have to be able to communicate richly in mass. And how do we do that? And part of the answer to that might be we communicate in smaller groups, and that information then is sort of propagated up the hierarchy or something. Maybe. I mean, the slate is wide open here. So this is the question to the world. How can we communicate richly in mass such that our purpose might be fulfilled? Our purpose of achieving and maintaining vitality into the future, right? So that's the big picture. And then what are the many tools or social norms or educational processes or any number of things that lead us to fulfilling our purpose, our intrinsic purpose, I should say, our biological purpose in a sense.
Nice. John, I hope that people clip that out or hear your question and really consider it. And what it makes me think about on this slide, and to return it to active inference again, is really like the rhetoric of participation, because in a reward maximization culture, things like communicate, it's like, but not now, we have decisions to make. Whereas when we reframe about reducing uncertainty on a multi-scale, so individual and shared generative models, it's like, have we communicated enough to even know each other's generative model? Because once I know that your generative model includes this dietary restriction, I don't need 100 text messages a day. I actually can generate recipes that are going to be compatible with you. So it's not like we just need to have more communication or a different kind, or these two people need to talk, or some sort of secret trick. It's actually that we can balance a lot of these sometimes locally contradictory needs. Like, choose two, and you could find a situation where they align on this list, and you could find a situation or imagine a situation where they diverge. And the power comes from being able to have that goal directness and the epistemic gain. And then potentially through peer mentorship or through extended cognitive architecture, we could be able to mark, where is there a yellow flag? Where is there a red flag? Where do we need to pull back and share more about one person's generative model? Or how are we working as part of an integrated unit that's reducing uncertainty given the preference vector, rather than, well, if we each just make as much money as possible, then the group will have as much money as possible, right? So this is a different way that we can go about having that conversation. And as hopefully we're drawing out, it's something where everyone's perspective isn't just a goop to be formed. Their perspective is their contribution and their value.
Yep. Yeah. Good. We can also look to biology too. How does how does the cells of a body make decisions? Like how does the liver know what to do and when to act? How does the heartbeat know when to speed up or slow down? There's rich communication that happens multi-scale, some local, some distant, through hormones, through messengers. There's enormously rich communication that happens between tissues and cells in order for all the pieces to understand what the what is necessary now. Right. So we can. This is an open question. It's a clean slate. There's great potential for the science world and other communities to move forward of this question of how do we richly communicate and make decisions together? How do we do that? And there's lots of biological examples for us to look at to gain inspiration from.
So a question from the chat just before Stephen, from Yvonne, just about the tools. How many people have used the kinds of tools that you're suggesting, or it sounded like you suggested that it didn't exist, but what is the preferred field for a startup, from Yvonne? Where is this coming out of, this sort of tool for communication and collaboration?
I'm not sure I understand the question exactly. Where is it coming from?
He asked, what is the preferred field to make a startup in for this kind of a tool?
Field.
Like, would it be in the field of industrial engineering, or?
Well, so I have ideas in my head of how we might, start to build such tools. And the reason I'm thinking about it is for this very problem of how do communities communicate? How, if this club model if we were to move forward with studying this club model and eventually developing a field trial with a club model, how does communication happen within that club model? So that's my interest, is the application to this problem of societal transformation and demonstrating new ways of cognition at the local level via clubs. But obviously, if you had a tool that could do this, there would be tremendous opportunities for others to use the tool too. This is just one example out of thousands you might think of, but I work in the utility industry, and I've seen how messages get transferred from, a caller calls in and says, there's an accident, there's a wire down, there's sparks flying, there's children around, there's some kind of rich situation happening that others need to know about. And by the time that message gets to the person in the field or in the truck, it might be quite garbled. It might be not unclear at all what the problem is or what the dangers are or what the situation is, right? So that would just be one example of how industry might use a tool for better communication. And there would be many more examples you could think of. So my guess would be that if the science community moved forward with this problem of how do you richly communicate with a large group, that those tools and the concepts that would come out of that could be applicable to a wide variety of industries and to this particular question of how does the club model work and how do communities cognate.
Thank you, John. Stephen, and then anyone else with a raised hand.
Yeah, thanks. I suppose this sort of reminds me of some of the principles. Actually, systemic coaching can be an interesting area. Like we're looking at coaching groups and the system. It seems to be that. And I was just wondering if you've encountered the viable systems model, Stafford Beer's viable systems model, because I think that some of the active inference work can recast that. Because you've got not just levels of regulation on the body, because it's based on I think it's the body on the nervous system of a frog, or different nervous systems, but that doesn't necessarily have that bottom-up teleology that you get from active inference. Doesn't necessarily have the idea that the lower levels also know something. It tends to be the higher levels are regulating the lower levels. So, but that might be something to look at as one area that's really interesting. And I just thought I'd mention that in case.
No, great. those are the kinds of ideas that you would want to explore as you build the kind of tools we've been discussing. And on that topic, the goal is not to build one tool that does all of this, right? We could have many tools. We could, different groups could explore a variety of approaches and tools, and some depths of simplicity and complexity, and there's room for many discussions on this topic, right? One other, just to kind of continue with you, the idea of coaching. I've been around enough folks in my life to realize that some groups and some people are really skilled at communicating and talking with others, and facilitating group conversation and things like that. And many times I've been just so impressed with the ability of certain groups or certain individuals to kind of facilitate communication and show by example what healthy communication looks like. And at the same time, I watch TV I see TV shows of terrible examples of how to communicate, examples of dishonesty, examples of manipulation, examples of holding back, examples of confusion, examples of shallow thinking, and social norms. Part of this whole process would also be to like the club model, it would be to develop social norms that are useful for the community, right? That are reinforced, healthy behaviors or healthy ways of communicating, healthy skill development that would help the community to better process the information it has, right? So that kind of coaching is available too.
And this is something in the narrative as active inference we talked about. When we see representations of communication, like they are upweighted, our priors are updated to think that those types of communication are more likely, or that they're prevalent, or even that they exist at all. And then we fulfill that prediction by reducing our uncertainty about our own behavior and our own thinking through other minds of other people's behavior, thinking, well, what happens when there's two people and is the one that cuts in front? And then you're not surprised when they do it. You're not surprised when you do it. But there's also a way to show representations of that not happening so that it will not surprise either person when they both slow down. And that shows how our intersubjective level of computation is something that is influenced by both the bottom up, the sensory input, and the top down with our cultural scaffolding. And so systems in change need to be able to resonate from the small to the large, or there's going to be some pathologies. So Stephen, and then any other comments?
So this actually could be an interesting, or could inform anyway, the types of questions that could pose to Carl Friston himself, around some of these practical implications. So we could have these in mind. So I was just thinking, do you have I wonder if you actually have thoughts about, are there holes in this, or are there questions around where this whole field of active inference is sort of going in the sort of global sense, and whether you've thought, I wonder what Carl Friston would think about that. Anyway, it's just a question to put out there.
Carl, if you're listening, feel free to join in. No, I would love to. One of the many ways to start this whole process off would be to have a conference where we get together some folks who have experience in these fields, in a variety of fields, who could offer their thoughts and cautions and encouragements, whatever they may be.
Well, John, on June 21st, 2021, Carl Friston will be joining us for a little symposium. And in another sense, we have a nano symposium every week. But any type of logistics or organization that are the enabling architecture is what ActInf Lab is there for.
Great. Fantastic. Fantastic. I maybe should say too, we've been talking about active inference, and obviously all of us are interested in that topic, but it could be that the active inference 2.0 is called something else. It goes, like we learn something in the next decade or whatever, and active inference is no longer, like we've moved beyond that, and now we're talking about some other thing. What the important aspect of this for us is, how does cognition happen? How does, how do biological organisms structure themselves and orient themselves and organize themselves in order to process information, and how does that work? So whether it's active inference or whether it's something else, sure, everything evolves. We learn as we go. So it might be, next year it might be a different word, but the concept is, how do we achieve and maintain vitality into the future? That's how do we fulfill our purpose?
And even today, for different non-English human languages and for computer languages, the word is already not active inference. And so that's why it's always so rewarding and valuable to be very clear on what active inference is, which parts are drawing from Bayesian statistics, from complex systems, from predictive processing, from all of these other areas, instead of thinking that we need to reinvent the wheel, because we certainly don't. We're also just a part of the cognitive architecture, and it'll be a quite interesting ride for sure. So maybe in the last 15 minutes of this point one, John, help us via another slide or by raising another salient question. What can we, as listeners and participants, think about in this next week to kind of simmer during this week between our two sessions?
Okay. Maybe next week we'll talk more about, we've only covered 2 slides here. We had, I think, like 60 slides we could have looked at. We covered 2 of them, or maybe 3 of them. But the goal here was to talk about part 3 of the paper, which is design. So I think maybe for our listeners, maybe the question of how would you actually do this? What would in part 3 I spend some time talking about a prototype called what I call the LEADA framework, Local Economic Direct Democracy Association framework. And the emphasis there, it is the concept is a full integrated systems approach, but the emphasis in the simulation trial that I published is on economics. So just take that alone. What would a fundamentally different economic system look like? How would it function, and how could it apply to a club model, implemented at the local level? What might that look like? And when I say economic, I mean economic / financial / monetary, institutional, all of those things wrapped up into the word economic. How would that look? What are the possibilities?
Great.
We'll go there next, maybe.
Great question. One thought is eco, and ecosystem and economy. It's like they start with the first 3 letters. They're so close. They're almost on the right track with an ecological perspective on economics. Yet you add one more letter and it changes from ecology to economics. And all of a sudden it's like never the twain shall meet. So it's an awesome question to be rethinking how these different intertwined systems relate, just like intertwined systems in an ecosystem of primary producers, prey animals, predators, renewal, etc. Right.
So on that, just to follow that up just a little more, what is an economic system? Before we go about designing new ones, what is the purpose of an economic system? We ought to ask that question first before we jump into potential designs, right? So what is it supposed to achieve in the first place? And I think for some listeners, or for the general population, at least, if you ask that question, the answer would be duh, an economic system is about allocating resources back and forth, choosing who gets what and how resources are used. But I would argue that that's not at all what an economic system, intrinsically, potentially, what an economic system is. I would say an economic system is exactly what we've been talking about so far today. It is a cognitive system. It is a different variety of cognitive system that allows a community to cognate in a slightly different way. Like a governance system allows a community to cognate in one way, a legal system allows a community to cognate in a different way, and an economic system allows it to cognate in a different way. So if the goal is functional societal cognition, what does an economic system look like?
one thought on that, and using the body's intertwined signaling systems like neurological, chemical, etc., from the point of view of the ribosome, the protein translating machinery, insulin is just another peptide. It's just linking the amino acids together and it's making a protein. But to the point of view of a receptor, the insulin molecule is an affordance for binding. And then to the point of view of the downstream signaling cascades inside of the cell, we start to see semantics enter into the picture, and then there's a turnover for the insulin, and there's lactate being shuttled from the muscles which are using it, and they're calling out for help through these different mechanisms. So it's like a cargo ship might be carrying something, and it's putting it in a box, and it's just moving it like an encrypted message. It's just moving the information. It doesn't need the semantics to be able to relay the information. And similarly, when there's these intertwining systems, it's like that one insulin peptide can be handled by a producer, by a transporter, by a signal detector, by a degrading enzyme. And the idea that all of those pieces are, you could just change one out or you could remove one, it wouldn't be the same system as a whole. So Stephen,
Right.
And then any other thoughts?
I like the hormone reference, as I think that the nature of the hormone system, where the hormone gets released into the blood, let's say the blood, and it travels around the body, it is actually maybe closer to this idea of a message passing kind of signal going out there, sort of sense, in sort of a general way, which is, and maybe this is something that the economic system does, right? And you can't do that so easily through necessarily just dynamical processes with people, right? It's like, okay, you can kind of infer things, you can sort of build things up, but okay, you set up a pipeline of value distribution, or at least the information in relation to value distribution and how that can be processed, and you can release your hormones, which is basically money or budgetary predictions, into that system, and it flows, right? It flows around it and it gets picked up, and it becomes more like a traditional signal that can be computed. But you can't put out the dynamical system information because it's not a thing. It is dynamical. So there's something interesting there, I think, around that analogy to that.
It's the system. It's the system we're working with to be able to explore how message passing algorithms, instrumentally used by us as curious and motivated investigators, allow us to act in the world to reduce our uncertainty about blood sugar.
So following on that, the question 2 for the public is, what is money? Like in its best sense, what is money? So we'll try to tackle some of that next week when we meet again.
Yep. So just on a closing note, we heard 2 big questions right there at the end. How can we actually do it? And it would be awesome if people could read, especially the 3rd paper in the series, and look at the LEDA framework that John has proposed. And there's a simulation there, and it's a scaffold for a lot of rich discussion. So on the how can we actually do this, we want to hear many perspectives as well as people's thoughts on the 3rd section of the paper. And then the second question, what is money? Which is, of course, a fascinating question for history, anthropology, game theory. So many different areas converge on what is money, and it's a system in flux, as we see quite literally day to day, depending on how closely you follow crypto.
Right. Thank you, everybody, for joining. This has been fantastic.
Awesome discussion. So everybody who's watching live, thanks so much for participating. And next week in number 21.2, we'll have a follow-up discussion with you, John. So thanks again for your engagement and for really giving us this foundation with the multiple precursor videos, because it really helped. And I think this is going to be a great conversation sequence. So peace out, everybody. See you later.
Bye.
Thanks. Bye.
Thanks. Bye-bye.